Okay, so I guess we should start. Good morning. My name is Paweł Skrzypek, and together with Alicia Reniewicz, we will present how to make the autonomous multi-cloud deployment using the different type of the components, including also the serverless components. So let me share the screen. Okay. Can you see my screen? I hope.
Yes, yes, we can.
Good. Okay, so thank you for the invitation to be here. We have yesterday a workshop related to this multi-cloud deployment, so this session would be much faster than on the workshop, but we will try to provide key information. I will start with the slides and some introduction, and then Alicia will make a short hands-on session and show how it works live. Just a few words about us. Alicia is technical leader in 7 Bulls. Ala is leading the development of the Melodic platform, which we will show it today. And I'm working as a cloud computing architect in the same project. And today we want to tell you about the Melodic, one of the multi-cloud deployment and optimization platform. The idea behind the Melodic is to be able to make a seamless, transparent, and optimized deployment to the various cloud providers. So the Melodic is your transparent way to deploy application into the different cloud, including the optimization capabilities in the exactly same way. Melodic is able to deploy virtual machines, containers, and also serverless components. We are working on adding new services and new features. And the most important thing is that Melodic is open source. It can be downloaded and used. I will provide the link to the all materials websites at the end of the presentation. So why to use that multi-cloud platform, management platform, instead of just using the one cloud providers? Because it is the simple and probably easiest way to use multi-cloud. Multi-cloud has many advantages, has also some disadvantages, but if you decide to go multi-cloud, then it's worth to use the multi-cloud management platform instead of the manual deployments or semi-manual, semi-automated deployments to the different cloud providers. Also, for Melodic, it is able to have the unified way of deploying virtual machines, containers, serverless, and big data stacks. Currently, we are supporting Spark, and we'll try to show how to deploy that to the different cloud providers. The deployment is fully automatic, so there is no need for the manual work. And the very important advantage of the Melodic is automatic optimization of cloud resources using advanced optimization algorithms and capabilities and unique approach based on the utility function. The first step is to model the application. So we have the cloud agnostic modeling language called Camel. It is based on Tosca, but extends Tosca because we need to provide additional elements to be able also to optimize the deployments. In the Camel, you can model your application components, connection between them, security rules, and also model requirements for the infrastructure. You are not modeling direct infrastructure, so you are not assigning directly to the given type of the virtual machines to the components, but you provide the requirements which are used in the optimization process. So in this Campbell model, you need to provide the requirements, constraints, for example, the constraints on the budget, constraints on the number of the virtual machines, and so on, and utility function, which is the way how we can decide which deployment is better and compare different deployment plan. Thanks to that, we are able to describe application and infrastructure in the cloud in the unified and cloud agnostic way. What is this best deployment? Probably that's the biggest differentiator and unique feature of the Melodic, but first, we need to know what is the current state of the deployment. So we are able to collect the metric of the running application. We are collecting both technical metrics like CPU and memory and business metrics, which describe the business behavior of the application, like, for example, average response time to the user or how long the given job take. Based on that metrics and other parameters of the cloud deployments, like number of the virtual machines, price for the virtual machines, we are able to construct the utility function, which is different for each particular application, and it is possible to make it very flexible and focus on the business value. Yeah, so we are not optimizing to use the less CPU or use the memory, but on the average response time to the user or average time for the processing given workload, of course, including other aspects as well. I will tell more about that in the use case application section, and also Ala will show that live. And why this utility is very important, yeah? Because usually in the optimization, it is some kind of the trade-off between the cost and performance and availability and other factors. If we want to minimize the cost, the best way is not to deploy the application, because in that way the cost is zero, but the performance is zero as well. Yeah, but usually we need to find the balance between the performance and cost. So we want to have the performance on the certain level or better and minimize the cost. We also want to increase the availability, so to have more than one instance and so on. So there are many factors which should be considered in the utility function. And all of this is done automatically by the Melodic, so you can consider Melodic like a smart autonomic DevOps solution. And how it works. The first two steps are manual, so the modeling and setting initial values of the parameters needs to be done manually. But after that, everything is done automatically. So first step is to calculate initial deployment, so to find the optimal values of the optimal deployment based on the provided values of the parameters, which are initially set by the expert, and then to make automatic deployment to the selected cloud providers. After deployment, Melodic is automatically started to collect metrics, and based on the values of the metrics, Melodic decide if the new solution should be, if the current solution is not optimal, and the new solution, we should look for the new solution. This decision is based on the values of the metrics. If the certain metrics exceed the value through the defined threshold, then the new solution, the Melodic is looking for the new solution. We call this service level objective. If this service level objective is violated, then we are looking for the new solution. Melodic is built in the typical microservice architecture. We have multiple microservices. We are using the ESB as a control plane to integrate that services, and we are using business process engine to manage the flow. Yeah? So it's very flexible, and it's quite easy to extend or change that process thanks to that architecture. So that's in the melodic, but also we are continuing the work, and we have another project called Morphemic. Within that, we want to add new features to the melodic. So these features we won't show today, but I hope that it would be possible to show it in the future. First feature is the polymorphic architecture, so ability to change the architecture of the application to have the biggest gains from the optimization. So we are able to change from the virtual, we would be able to change from the virtual machines, containers, serverless jobs, and also to use the hardware accelerators like GPU and FPGA to maximize the performance and minimize the cost. Second concept is proactive adaptation, because currently we are using the current values of the metrics from the given moment in the time, but the adaptation, so adding new resources, takes time, and after the exceeding threshold, it takes 5 to 10 minutes to find new solution and to deploy new virtual machines. In the proactive adaptation, we want to anticipate the future workload, the future resources demand, and adapt proactively. So to adapt before the demand occurs. And for that, we are using advanced machine learning based forecasting method, time series forecasting method. And based on that forecasted method, we have constructed the proactive utility function, which is able to anticipate what will happen in the future. And how to use the melodic, what is the purpose, who can use melodic, and what are the benefits. I want to share two examples. One is the AI investments company, and the second is the Biotech Research Institute. The second application will be also shown by Ala live. So AI Investments is the Polish fintech company which aims to use advanced machine learning models and methods to optimize the investments portfolio. They are using heavy computational intensive models and solutions, so it is very important to do it in the optimized way. And typical business goal for the AI investments is to train, for example, 50 forecasting prediction model in 1 hour, of course, using as minimal number of resources as possible. And how it is done using melodic. So initially, the investments analyst in the AI investment is starting to train models. And initially, the on-premises resources are used because, they are already bought, available. So it is the most reasonable to start using these resources. But of course, usually these resources are not enough. And in that case, melodic is calculating how long it takes to train given models on the on-premises resources. If it's too long, like 3 hours, then automatically new resources in the cloud are added. Of course, the optimal one. So melodic is looking for the most optimal optimal offers and add the cloud resources in the selected cloud providers. Then checking again, if it's still too long, then additional resources are added. And if the processing time is estimated to fulfill the business goals, then the training is continued, and after the finishing training, Melodic automatically remove all of the resources, the cloud resources, to save the cost. So it is very simple, but it's also extremely beneficial, especially for the companies which are heavy using the cloud and computer resources. Yeah, because thanks to that, we are able to effectively optimize the resource consumption. We can scale our machine learning workloads and training, and we can optimize the work efficiency according to the budget. And one additional advantage of that approach is also the increasing reliability and high availability of the application. And we have very good results. So the automatic dynamic management of the resources is able to save for the AI investments over 175,000 US dollars in 3 years perspective, yeah, comparing to the cloud-only solution. So definitely this multi-cloud and hybrid approach give the advantages. And the second application is a Genome application. It is application used to process and compare genome data. This is a typical Spark application used by one of the Polish universities to make the research related to the genome and to find the mutation. And again, a researcher in the university is starting to processing job using the private clouds, and Melodic is looking how long it takes. If it takes too long, then additional resources are added. Melodic is continuously checking how long it would take to process the data and manage the resources accordingly. Yeah, so that is again very typical but very popular case using one of the most popular big data framework. Okay, and that's all from my side. Now I will show the real hands-on session, how to use the Melodic, and we'll show this workflow, what to do to use the Melodic. Okay, let me stop the screen, and Ala, please show it live.
Hello everyone. Now I try to share my screen. I hope you can see it.
Yes, we can see.
Okay, great. During my part of presentation, I would like to present you how to automatically deploy own application by Melodic platform. I will perform deployment of Spark-based application. We will monitor application metrics and observe reconfiguration process, which is done by Melodic for reasons of optimization. My Melodic platform is installed on a virtual machine and it is up and running. I'm logged in. And the first step in Melodic usage is the defining of cloud settings. In provider settings bookmark, we can check and update providers' credentials and options. As we can see here in cloud definitions for providers view. Filling these values is required in order to perform successful deployment because they are used in contact with providers, for example, by creating virtual machines instances. On my environment, I have already defined these values for Amazon Web Service and for OpenStack provider. Of course, it is possible to define such settings also for Azure Cloud Provider or for GCP, for example. In such definition, we provide cloud credentials and properties. For example, settings for Amazon Security Group or set of private images which we would like to use in our deployments. When our platform is properly configured, we can go to the deployment bookmark. Today, I would like to deploy Genome Application, which was described by Paweł a moment ago. Before deployment, we need to model our application with its requirements in camel model, which is human understandable and editable form. After that, such model is transformed by dedicated tool to XML format. Form understandable for melodic. I upload such file here by drag and drop, and I choose upload option. Now our model is being validated, and after that it will be saved in database. In a minute, I will be asked for field values of AWS developers credentials. Providing these credentials is required in order to save results of our Genome application in AWS S3 bucket. But in view of security reasons, we shouldn't put them directly in camel model file, so we use placeholders in camel file, and after that we need to provide these values here. In this case, it's not the first upload of such model on this virtual machine, so these variables already exist in dedicated secure store. I can verify them, update if they were changed, and choose Save button. Now, my model with my secure variables is successfully stored in database, so I can go to the next step. Here I need to choose which application I want to deploy and which cloud providers I want to use. I have now one uploaded model for Genome application, so I choose this model. And during this deployment, I would like to focus on AWS, so I choose only this cloud definition. Thanks to that, Melodic has credentials for this provider. And now I can go to the last step in this part, where starting deployment is available. After starting the process, in a minute, we are moved to the deployment process view, where we can observe the progress of that. In the meantime, I would like to briefly describe application which is being deployed by Melodic now. Genome is a big data application which performs some calculations and saves results in AWS S3 bucket. So we needed to provide developers' credentials to AWS. Genome's performance is managed by Spark. In Genome application, we use Spark as platform for big data operations, which are performed parallel on many virtual machines and managed by one machine named Spark Master. Spark Master is available by default on Melodic platform. Melodic creates proper number of workers as virtual machines, considered our requirements from camel model. Thanks to measurement of application metrics, Melodic makes a decision about creating additional instances with workers or about deleting unnecessary ones. Spark divides all calculations, named tasks, between available workers in order to optimize application performance and cost. Please let me come back to our process now. Fetching offers is the first step of deployment process. We have information about current total number of offers from previously selected providers. So in this case, from AWS. From these offers, Melodic will choose the best solution for worker component. After choosing this box or offers option from menu, we are directed to view of all currently available offers. There are clouds with my credentials to AWS, hardware, with such parameters as cores, RAM, disks, etc. A list of available locations where our virtual machines could be located, and images list. Here we can see only our private images, but of course all public images are available for us. The next step of process is generating constraint problem. Constraint problem is generated based on our requirements defined in Camel model. In simple view, there are visualized all variables from constraint problem with their domain values. For genome, worker cardinality, worker cores, and provider for Spark worker component. Detailed data are shown after click on this box. Here are presented list of variables again, but with additional information about component, type domain, and type of the domain. Here we can see, for example, that we would like to have from 1 to maximum 10 workers, as we have such variables as worker cardinality. Also, we can see here utility formula. It is used for measure utility of each possible solutions and choose the best one. List of constants with types and values. They are created from user requirements and are used in melodic calculations. Here we can see, for example, minimum and maximum values for cardinality of Spark worker instances, or the same type of restriction for number of Spark worker cores. And the last element here, list of metrics with their types and values. They describe current performance of the application. Thanks to them, Melodic can make a decision about triggering the reconfiguration process, which means creating new additional instances or deleting not fully used ones. Thanks to metrics, Melodic can do the most important task, which is cost optimization. We back to process view. When constraint problem is generated, it is time for rezoning. Melodic finds here the best, the most profitable solution for the problem defined by us. When rezoning is completed, we can observe information about calculated solution, utility value, and values for each variables. In that case, 1 as worker cardinality, 4 as worker cores, and provider for Spark worker from 0 index, so it means AWS. The next step in process deployment is deploying. Here Melodic performs operations based on calculated solution. This solution is deployed. For each application, a component, Melodic creates proper instances, remains them, or deletes. So in that case, now Melodic is creating for us one worker component in AWS with 4 cores. If you want to have a more detailed view, it to see the process view using Camunda. And in the meantime, process is successfully finished. And also we can see the more detailed view in Camunda by choosing the advanced view option. Camunda is a tool for modeling processes in BPM and standard and for management of them. And here I need to log in with the same credentials as for a melodic platform. I choose running process instances. Now I have only one process, and after choosing of it, I can see detailed view of the process with all the variables, and we can see each step of the whole deployment process. So after performing each of these steps, melodic went to the last step, and here we can see that this is the end of the deployment process. This is quite complex view, and it is more for technical user, but also such view is really useful, for example, during diagnostic of some problem. We can see that our application is successfully deployed, so in such case, we can check the result of the deployment. In your application bookmark, we have list of deployed virtual machines and functions. In case of Genome Application, we deployed only virtual machines, and we can see here our one Spark worker with information about it. So information about public IP address, private IP address, the provider, and the location where our VM is created. What is more, we have here button for web SSH connection, which is really useful in testing process. When I successfully deployed Spark application by Melodic, I can go to the Graphana by choosing monitoring application options. Graphana is a tool for monitoring, displaying statistics and metrics. So we use them for monitoring performance of applications deployed by Melodic. I need to log in, of course. Each application has own metrics and own parameters to control, so we need to create dedicated Graphana dashboard for each of them. Also, Genome Application has own Graphana settings, and we can find it here. We can check that metrics are being correctly calculated and passed to the Melodic in this view. And now it is the initial state of the whole process. So now we can see only the first measurement. And here we can see a color of limitation of traffic lights, which inform us if application will finish on time. Now it is the initial state, so the calculations cannot be so precisely. And in a minute we will see probably the more precise result. Now now we can see that the time left to the finish of the calculation is equal to 58 because the indicated time because the expected time was indicated in camel model, and it is equal to 60 minutes. So we can observe how many minutes left from this time after our time left value. So we know that that only for 3 minutes the calculations have been done. And based on current performance, it is calculated the estimated time left. So now it is equal to 81 and it is higher than time left. We can see red light, and also on the left we can monitor number of instances, and I think that I choose here last, for example, 15 minutes, because now we will see only the current deployment. Okay, so now we can see that we have one instance after starting the deployment, and here it is created for us the new instance. On the bottom, on the simulation chart, it is presented the number of remaining simulation. This value, of course, is decreasing with performing next tasks by Spark. On the right, on chart named number of cores, we can see value of minimum cores needed to finish calculation on time. This is the green one. And current total number of cores, so the yellow one. So now we have 1 core, and we would like to have now 7 in order to finish calculation on time. So based on these calculations, we can see that Melodic claims that more cores are needed, and also the estimated time is higher than time left. The light is red, so there are signals that our application needs more resources. In such situation, Melodic makes decision about triggering reconfiguration process. In the background, reconfiguration process should be down, and even here we can see that new instance is being created for us. Thanks to monitoring Genome Application in Graphana, we know that our application runs because metrics are visible. But it is another way to direct control of Spark application by go to Spark Master website. Spark Master is built into Melodic machine, so I use the same IP and 8181 port. In this view, we can observe management of performing tasks by Spark Master. There are lists of available workers, so now even we can see that new workers are created for us, and now we have 2 workers. So this one from the first initial deployment, and the new one created after the reconfiguration process. So now Spark Master divides all calculations between these 2 workers. Decision about creating the new workers or deleting some of them are made by Melodic based on measurement of metrics. In such situation, new process is triggered and it is named reconfiguration process. And we can observe the current process in Melodic UI. I go to process view, and here we can see the last process. It is the reconfiguration process. In reconfiguration, Melodic doesn't fetch new offers and uses the same constraint problem as for initial deployment. For these reasons, as the first step, we can see rezoning. As a result, it is available for us new solution, which is already deployed. And now Melodic claims that 2 workers will be needed. This solution is deployed, and now we can see that reconfiguration process is finished, so our solution is ready to use. We can check the result in your application bookmark, and yes, now we have 2 workers. Also, we can see this worker in Spark Master UI, and now I go to Graphana in order to check the result, and we can see a new available worker. Now the time left, now the estimated time is still higher than time left, but not so much as at the beginning. So the performance of the application is a bit better, but Melodic still claims that more resources are needed, so we can expect that in a minute the new reconfiguration process will be triggered. In case of Genome, in the first part of performing calculations, additional workers are created as far as Melodic measures that the effectiveness of application is too low. In the final part of performance of Spark jobs, Melodic makes a decision about deleting unnecessary instances when it is visible that application will finish on time. And now we can see that new nodes, so new virtual machines will be created. Also in process view, we have now new reconfiguration process. Right, so we successfully observed reconfiguration process for Spark application. And this is the end of Spark application deployment done by Melodic demonstration. We could see how Melodic automatically ensures high performance of applications. Of course, it is possible to support also serverless deployment of AWS Lambda, Azure Functions, and so on, as well as Docker containers deployments in the same way. Thank you very much for your attention. And if you have any questions, please ask.
Yeah, thank you, Ala. Just in time, we were able to present that. If I may share quickly the screen with
Yes, of course. So I stop sharing. Thank you.
Perfect. Thank you very much. Okay. Hope you can see my screen. Just 1 minute. I wanted to say that if you want to use and download, you can download Melodic here at Melodic Cloud. As I said, it's open source, released under Mozilla public license, so you can freely use. And also we want to encourage you to contribute in Melodic development. Also, it is possible to follow Melodic in the social media, LinkedIn, Twitter, Facebook, and here is the link for the Melodic website. So thank you very much for your attention, for participating in that session. Thank you for all of the questions. I hope I answered them. Yeah, I hope you would find this presentation valuable for you. Thank you very much.
Thank you very much.
Bye.
Bye.